In this question, it is given that let this thing represent the principal argument of the complex number z, and mod z equal to 3 is also given to you, and it is also given that argument of z minus 1 minus argument of z plus 1 is pi by 4. These two curves intersect at, you have to find the correct choice, that is the number of points where these two curves are intersecting. This equation clearly represents a circle with center 0, 0 and radius 3. It's very obvious. The main thing is that to understand that concept, let me explain you this concept first. Suppose there are two lines and the point where they are intersecting has complex number z1, z2 is some other point on this line, and z3 is some other point on this line. And suppose you have to find this angle. Note that whenever you have to find the angle, first of all mark anti-clockwise direction here and name the points as A, B, C. Then remember that argument of, now see where the angle is starting. It is starting from AB, therefore AB vector will be written in the denominator, AC vector will be written in the numerator, and this will be equal to theta. That is argument of this complex number will be equal to theta. And further it means argument of z3 minus z1, and this means z2 minus z1, this is equal to theta. And now this equation can be written as argument of z minus 1 upon z plus 1 equal to pi by 4. Clearly 1 is somewhere here, minus 1 is somewhere here. Let us name this point as A, this point as B, and variable point as P. It is according to this information, as I told you, it means argument of, because it is z plus 1, that is z minus minus 1, that is it is representing the BP vector, and z minus 1 means it is representing AP vector, because BP vector means complex number of P minus complex number of V, which is same as this. AP vector means complex number of P minus complex number of A, that is z minus 1. This is equal to pi by 4. And because the angle is positive, it means angle must start from BP vector, go up to AP vector, and angle must be pi by 4. If this is the diagram, it will mean that angle has to start from BP, go up to AP, and angle should be anti-clockwise. This is anti-clockwise direction, and it is starting from BP going up to AP, and amount of angle is pi by 4. Hence the P point will be moving somewhere above x-axis and angle is constant. Note that had the angle be minus pi by 4, in that case the point P would have been below x-axis. And now if the angle is constant between BP and AP, it means it is sure that the locus of the point P will be a circle, but it will not be complete circle, it will be this circle where angle in this segment is pi by 4. It is not semicircle. Angle in this segment is pi by 4. And because the angle is constant, locus of the point P will be a part of circle. And if you want to find the center and radius of the circle, it is clear that center will be at a point, say C, such that because this is pi by 4, this will be pi over 2. This is pi over 2 means this is pi over 4. And because this length is 1, hence this length will also be 1. That is, the coordinate of this point will become 0 comma 1. Hence we have concluded that this equation represent all these points for which A and B are the endpoints of the major arc. And previous was circle with center 0 0 and radius 3. Circle center 0 0 and radius 3, that is, we get a circle with radius 3 and center 0 0. This will be a circle. Otherwise, it is clear that these two circles are not cutting anywhere. Still, for confirmation, it is clear that because this is 1, this is 3, circle cannot intersect here. And here, this height is 3 and this height is 1 plus radius. Radius is clearly root 2. Hence, this length is root 2. This length is 1. Therefore, the maximum height is root 2 plus 1. But height of this point is 3. That is, they cannot intersect anywhere. Hence, the correct choice becomes C.